Hi everyone, thanks for joining us today for today's Commercial Code Change webinar, and thanks for joining our SUHO webinar series. It's been a great 11 and a half weeks so far, really sort of trying to educate the industry around both the code changes and sustainable design. There's certainly plenty of other webinars worth checking out. For those of you who aren't familiar with SUHO, we're Australia's largest and longest running ESD firm. We've got a full suite of services through residential and commercial assessments, which is our bread and butter that we've been doing for years. And then in the sort of last 5 years or so have branched out into the rest of the ESD services related to like Green Star, sustainable design during town planning. We've got our own studio, and also air tightness testing. We'll move on and we'll get started. So as you're probably all aware, it's been a little bit of a messy code change but from 2016 to 2019. The initial grace period between both 2016 and 2019 lasted a year up until the 30th of April 2020. And from May 1st, it was officially the 2019 code. A few things have sort of happened since then. The WA government gave an extension for another year, so that's until May 1st, 2021, that WA projects can use either the 2016 or 2019 code. And then we've heard a few rumours around like Queensland and a few other places as well. But the main thing at the end of the day is certainly to check with your building surveyor or certifier as to which code they're expecting you to have the building compliant to. We've certainly seen a number of clients still coming through with projects that have already had a decent amount of documentation on, that they might have spent a couple of years sort of drawing up, and those projects are still getting through under 2016, so certainly worthwhile checking. Just as a general sort of understanding so that we're all on the same page, obviously there's two pathways for Section J compliance. There's the deemed to satisfy pathway, where each of your elements have to comply. That's your roof, your walls, your glazing, your floor, from a fabrics point of view, all need to comply. Traditionally, it's a cheaper assessment cost and still is, but is pretty much always, for 2016, was a higher build cost. And that's why under 2016 code, JV3 was so popular. In terms of SUHO's commercial assessments, 95% were JV3, 5% were DTS. And it's going to be really interesting to see how that changes with the new code, given that they've now changed a few things around. In terms of the JV3 pathway, most of you are probably familiar with it. It's the more holistic approach. We model the proposed building and then also copy that building to make a reference building, which has all of the deemed to satisfy requirements as inputs. And then as long as your proposed model performs better than the reference model, then you achieve compliance. In terms of why it was so popular and why it probably still is because it allows a more flexible approach. So it allows you to substitute different levels of insulation or glazing. You might decide that you don't want to have under slab insulation, or you would like to sort of lower the specification requirements for the glazing. And if that's what you're after, then it means that you can add additional insulation to, say, your roof, for example. It traditionally and still is a higher assessment cost, but certainly for 2016 always resulted in a cheaper build cost. So there's sort of four main key areas of change for this code. Obviously the building envelope, the fabrics, and the addition of thermal bridging into this commercial side of the code is certainly some big improvements. Then you've got the lighting and HVAC efficiency improvements, as the code tries to move towards eventually being a net zero code, I suppose, in terms of energy efficiency. And probably one of the biggest changes is the addition of thermal comfort to the JV3 assessment. So that's now required for all JV3 assessments, not for deemed to satisfy. We'll touch on that a bit later. So first we'll go through the building fabrics, touching on thermal bridging first and then going through the deemed to satisfy requirements. So one of the big changes is the addition of thermal bridging. Thermal bridging is where you've got any framing members that are effectively bridging the insulation. So you can see in the picture on the right hand side of the screen, the thermography sort of picture shows how the studs within that wall are allowing heat transfer to occur at a higher rate through the timber or metal studs as opposed to the insulation layers in between it. Under the 2019 code, we're now required to assess include thermal bridging in our calculations for roofs, walls and floors, and that's certainly going to decrease the effectiveness of your insulation. So we've got a quick example on the next page that sort of explains it a little bit better. If you consider a stud wall and you've got, say, your studs at 450 spacings, there's noggins throughout it, and whether or not it's timber or metal, that layer of insulation is being bridged by a timber or metal stud. You can see, and in this example, we've got our 2.5 insulation in the walls. Under 2016 code, there was no requirement to consider how those framing members were bridging the insulation, and so you straight up achieved R2.5. Under 2019, that's really going to change. So if it was a timber stud with the details on the left-hand side, you'd be looking at about an R1.8 R value for that layer, or that bridged layer. If it was a metal stud, you're looking at closer to R0.8, and that could be improved if there was a thermal break tape put onto those framing members. So you can really see from this example that previously in 2016 code you were achieving R2.5. Now you could be achieving somewhere between R0.8 and R1.8 depending on the timber or metal stud. Obviously that's all going to change depending on the framing system used, how far apart framing members are, that sort of thing. But really just trying to show, I suppose, the impact and the addition of thermal bridging for this code, and how it's realistically it's a more appropriate way of assessing how the insulation is performing, but certainly it's going to make achieving some of those R values a little bit harder. Secondly, I suppose, we'll touch on some of the DTS requirements. You'll see that most of the R values haven't really changed too much from 2016 code, but remembering that these are now bridged R values. So anywhere where we've got, say, ceiling joists bridging ceiling insulation, studs in walls, or floor joists bridging layers of insulation, that's going to reduce the effectiveness of that insulation and mean that these R values are slightly harder to achieve. So firstly, on roofs, most climate zones are only requiring R3.7. Melbourne is 3.2. Previously, there was a bit of a scale under the 2016 code where, depending on the roof colour, you were required to achieve different levels of R value, where you sort of got slight reductions in R value depending on the roof colour choice. Now, the roof colour requirement is just 0.45, and the big change is that now limits you to those 5 colour-bond colours on the right-hand side. Importantly, it also removes the option of zinc aluminum sheeting, which I know some clients are not so happy about. If you're looking to have a darker roof, or the client has to have it, then you're looking at a JV3 option to use the modelling process to allow you to have that darker roof colour. For floors, probably the biggest change is the addition of concrete slab on ground, requiring slab insulation in climate zones 1 to 6. Previously that wasn't the case, and it was only climate zones 7 and 8 that required slab insulation. Now all climate zones require it. And the interesting point here is that there's a table at the back of the code under specifications J1.6, which allows us to calculate the soil resistance value of the slab. So using that soil resistance value means that if you've got a larger slab, you're probably actually not going to require any underslab insulation. The tipping point is somewhere between sort of 300 to 400 square meters. It really depends on the ratio of the external perimeter and the floor area, which is something that we can very quickly calculate for you. And so that's another sort of point that's certainly worthwhile noting if you're tossing up between a deemed to satisfy assessment or a JV3 assessment. So yeah. The The other big change is that wall and glazing are now combined into one facade calculation. So this is something that's been done around the world for a number of years in a number of other building codes. Realistically, I suppose it's another more holistic approach and more sort of effective assessment of how the facade is going to perform. So there's two assessment methods that you can, or options that you can use. It's calculated per floor level. For method one, it's per orientation, so that's split up into north, east, south, and west. Otherwise, there's also method two, which is a more combined result. For those of you who are familiar with the 2016 glazing calculator, you'd be used to sort of seeing, under deemed to satisfy at least, a difference. Often you'll have some facades that have got a bit more glass, some that will have a little bit less, and often there would be one orientation that had a really high requirement for the glazing and others that were a little bit lower. Method two is going to allow you to sort of get a more average result, although it's not exactly an average. So it'll be sort of a more balanced result effectively for the glazing requirements. So we expect that most clients would probably prefer that option, given that it allows them to have a consistent glazing the whole way around the building. When we do our deemed to satisfy assessments, we provide both results, so it's easy for our clients to sort of choose which pathway they want to go, but generally, from what we've seen so far, method two is probably the more popular option. Either way, we've set up our SUHO facade calculator to plug in initially the required wall R value. Once you achieve that, then we calculate the glazing U value and glazing soil heat gain requirements for both method one and method two. In terms of the wall requirements, there's a little bit of a funny tipping point for 2019. If you've got more than 20% glazing, the walls are required to achieve R1. That's not particularly high. The codes, or the ABCB, have sort of decided that if you've got more than 20% glass, it's the glass that's really having the impact on facade performance. If you've got less than 20% glazing though, then you have some slightly higher R value requirements, and that's because obviously the walls are playing a bigger role. For daytime operating buildings, which is the classes you can see on the screen, generally they're lower requirements at about R1.4 for most climate zones, other than climate zone 1, which is R2.4. And then for nighttime operating buildings, you actually have some quite high wall R value requirements, and that's something so far that we've seen is pushing people towards JV3 for those nighttime operating classes. For climate zones 1 and 3, it's as high as R3.3, which is, when you're factoring in bridging, is like a fair increase in what was previously required. In terms of glazing performance, these two plots just show sort of a general description of, well, I suppose a graph of how the U value and the soil heat gain requirements have increased between 2016 and 2019. You've got your glazing U value on the left-hand plot. Your blue line is 2016, orange line is 2019, and you can see from about 25%, or before 25%, nothing's changed too much. After about 30%, it starts to really increase in the performance of the glazing. And we had a comment a few weeks ago, someone mentioning that although it is an increase, it might still only be, say, sort of Comfort Plus or something like that. It's completely agree. From a sustainability point of view, obviously, we welcome the increase in level of glazing performance. From a cost point of view, though, for some clients who are very cost driven, this is certainly a concern. So I suppose just sort of two sides of the market. For the solar heat gain, you can see that it's a more sort of linear improvement, probably around a solar heat gain of 0.1 between 2016 and 2019 requirements. We've got a couple of quick examples here for DTS solutions, just to sort of provide you with a general understanding of what some of the changes are. This is a school building, it's in climate zone 5, it's concrete slab on ground. There's about 35% glazing to the north, east and south. And it's all very well shaded with sort of between 2 to 4 meters of shading. So you can see in this example, like we touched on earlier, for the roof requirements, previously you're allowed different roof colors, and that just changed the the roof R value requirement for 2016. For 2019, they've simplified it just to a standard R3.7 for climate zone 5, obviously factoring in bridging. Importantly, as we noted earlier, the maximum allowable roof color is a solar absorbance of 0.45 or less, which is the 5 ColourBond colors that we touched on earlier. For the walls, the previous requirement was R2.8 in most climate zones, and the glazing for 2016 in the calculator actually allowed you to pretty much have any glass you wanted to. Single glaze clear would have been fine for this particular project. The 2019 result, you can see that for the method 1, R1.4 was required, and that's because of that tipping point for the glazing percentage. And you can see that the U value requirements have really picked up between 2016 and 2019, down to a high performance single glazed unit. Worthwhile pointing out that the solar heat gain requirement hasn't changed too much for this between 2016 and 2019 for this project because of the amount of shading. You'll see on the next example that it certainly has improved. It's just because there's 2 to 4 meters of shading around this building, and so there's actually no solar heat gain requirement. As we touched on earlier, method 2 in this case gives you the more balanced result for U value, being sort of somewhere between the method 1 result. And that's really why we expect that most clients will probably prefer this option. Worthwhile pointing out that the method 2 wall requirement was actually only R1, and that's because of the percentage of glass the whole way around the building that wasn't triggered for method 1. For the floors, in this case, for 2016, as it was in climate zone 5, there was no slab insulation requirement. For 2019, there is, but due to the size of the slab and that soil resistance that we touched on earlier, there's actually still no insulation requirement because you're achieving the R value just with the soil resistance underneath the slab. We'll quickly touch on this Class 3 welcome house, more so to touch on the glazing requirements. This one's got slightly less glazing, sort of between 17 and 30%. And in this project, there's only eaves shading the glazing, so they're probably sitting slightly higher up, and they're only about 900 mil off the wall. You can see in terms of glazing requirements between 2016 and 2019, the U values have certainly increased in requirement. And importantly, as we touched on earlier, the solar heat gain has certainly improved as well, and that's because there's less shading over this glass. You can see that for the method 2 result, that should be method 1 result up the top there, it requires R2.8 bridged as the minimum requirement, and that's one of those high wall R value requirements that we touched on earlier. And one of the key things to know here is that the glazing U value and wall R value are sort of in balance to an extent. So if you want to bump up those glazing U value requirements, you could add more insulation to your walls. If you're looking to increase the solar heat gain to give you a bit more flexibility with maybe some slightly clearer glass or something like that, it's all about the glazing percentage to the external walls and also, or the external glazing I should say, and also the amount of shading. So increasing the shading will obviously give you a more flexible solar heat gain requirement. Interestingly on this project, although it's a bigger building, because of the shape of that external perimeter, which is a bit more unique than the previous project, this project would actually require some level of slab insulation at about 0.4. Okay, so that's DTS. In terms of the JV3 pathway, by far the biggest change is the addition of thermal comfort. For this version of the code, it's all about achieving a PMV between -1 and +1. That's a predicted mean vote. It's based around some sort of studies that were done probably in the 50s or 60s, and the calculation is based around the factors that you can see on the right hand side. So that's like room related factors, which are air temperature, the air velocity, the radiant temperature from the sun, and the relative humidity. And then you've also got the human factors, which are what the people are actually wearing and also what they're doing in the room. So if they're in an office, if they're in a school, that sort of thing. To do the thermal comfort assessment, we use the same model as the JV3. So we're using a proposed model, and we're trying to achieve both the thermal comfort requirement between slightly cool and slightly warm for 98% of the operational time, and that's for 95% of the floor area. And we're also trying to achieve the energy requirement. So if you achieve both of those things, you're all good, you achieve compliance. If, rather importantly, if it's a building where thermal comfort just isn't possible to achieve, which is potentially possible for maybe some smaller modular like site boxes or something like that, if they've only got, say, if they've only got one window that might face east or west, which generally don't perform too well, particularly east, and it's lightweight with limited, well, probably no thermal mass, then it's probably going to struggle to achieve thermal comfort. And so generally we'd recommend doing a thermal comfort check first to make sure that it's actually possible to achieve thermal comfort, and then we'd continue on doing the energy side of it to make sure that you're ticking both boxes. In terms of other key changes, there's two of the main things are probably that there's two new performance solutions. So that's JV1 for Neighbours and JV2 for Green Star. Previously for these projects, you still had to do a JV3 assessment, even though you were doing a heap of modelling for Neighbours and Green Star. For 2019, I suppose they're just trying to smooth out that process so that you can use the same model that you're using for Neighbours and Green Star as your compliance to the building code. So importantly, both of those JV1 and JV2 options still require thermal comfort assessments, but as these buildings are generally high performing with high performance facades and that sort of thing, decent glazing, you pretty much guarantee that it'll pass the thermal comfort side of it. In terms of other things, there's been an overhaul of like a heap of the profiles, temperature range parameters, that sort of thing in the background. That's all input into our model, which is just something that we've been working on over the last probably over the last year, although it didn't take that whole year, obviously. This is just a slide that we sort of include in our workshops as a sort of general summary of some of the changes. Obviously that facade the facade calculations have certainly shaken up the glazing and wall value, R value requirements. The fact that concrete slab on ground floors now require insulation in climate zones 1 to 6 is certainly something that's a fairly big change. The higher wall R value requirements for overnight buildings. And then obviously for JV3, you've got the thermal comfort side of things, which is certainly adding an additional layer of sort of complexity around the JV3 assessment. It's no longer as simple as sort of just asking for a JV3 assessment and us being able to pretty much guarantee that we'll get you a solution. In terms of HVAC, we'll only touch on it quickly. It's become significantly more complicated, probably about double in the size, and that's due to obviously the efficiency increases in the requirements. And then there's also a number of new calculations around like pumps and fan systems, obviously trying to drive the HVAC systems towards being more efficient and producing less, at the end of the day, less greenhouse gas emissions. In terms of lighting, the other, probably the surprising thing about the 2016 code that it was based around T8 fluorescent lights. Obviously they've been sort of phased out for certainly a couple of years now, at least. 2019 is now all based around LEDs, so it's really the code just coming up to what's really pretty much industry standard now. That's meant that the lighting allowances have certainly decreased a bit. For example, offices were previously 9 watts per square meter, now they're 4.5. In our experience, that shouldn't be anything too scary, really. If you happen to have a room or a design that's just got higher levels of lighting, it just means you're going to have more control devices to increase the allowance to allow you to have those light fittings in there. Other notable changes for the 2019 code, under section F, there's now daylight factor analysis, which is mandatory for certain classes of buildings, and that's something that we can do using our JV3 model. It's sort of, I guess, killing two birds with one stone, that we can tick off those requirements for natural daylight as well as doing the energy efficiency. The offset for on-site solar and renewable energy has certainly been sort of clarified a bit more within the codes, not so much in the code itself, but in the handbook and the guidebook as well. Our interpretation is that on-site solar should be, or renewable energy should be, both stored on site and used for any of your Section J related services. The key thing there being that if you generate solar on site, really you pretty much have to have storage to be able to say that yes, it's going to directly be used for like your HVAC or your lighting that's part of the part of the building that we're assessing for Section J. The other interesting thing about this code change is that they've introduced a optional post-construction blower door test, which can prove that your building is appropriately sealed for air tightness. That's under JV4. It's optional though, so you can either do a post-construction blower door test to prove that yes, you are meeting the building sealing requirements, or you can go the traditional deemed to satisfy option, which is under section J3, and that's really just ticking off that yes, you've got door seals, where there's seals around your windows and doors, you've got exhaust fan dampeners stopping drafts from coming through them, and that sort of thing. Realistically, if you're going to do a post-construction blower door test, you would require those sorts of seals and dampeners to be installed anyway to be able to achieve it. So bit of an interesting one, but certainly something that we expect in the future codes to probably potentially be a requirement for buildings maybe of a certain size to be air tightness tested. Touching on our recommended compliance pathway for the time being, obviously we're 6 weeks into the 2019 code being mandatory, and as you kind of expect, most people have got away with using 2016 up until that May 1st deadline. So while everyone sort of gets used to the code requirements and what's sort of standard and what the best solution is, we're recommending a prelim DTS check as early as possible. That can be done pretty cheaply. Really, we're running a facade calculator, also checking the insulation requirements for your slab, for your walls and roofs, and just giving recommendations at that point that can sort of be done in sort of 2, 3, 4 hours, depending on the size of the project. If you're content with that DTS result, then you can continue on with the DTS assessment. It's the cheaper compliance in terms of compliance cost. It's the cheaper pathway anyway. If you're dissatisfied with that result, or you would rather a more flexible solution, maybe also your project or the client might just desire has to have a dark roof, or say you're trying to maybe reduce the requirement for having slab insulation if your building's sort of a smaller footprint, then we can go down the JV3 thermal comfort pathway, producing a final JV3 report. The DTS check is really, I suppose, just handy to indicate, even if you're planning on using the JV3 pathway anyway, it's still a handy sort of input just to know what the likely requirements for your glazing and insulation might be as a sort of worst case benchmark. And then we can continue on down the JV3 pathway and look for more cost-effective solutions if that's what you and the client are after. We've certainly seen a few clients use DTS checks so far for tenders and stuff like that, just to sort of get a bit of an understanding of, if they're quoting on projects, what the likely cost requirements will be, particularly around glazing. I've got a couple of other handy tips here, which we'll quickly touch on. Obviously, from a Section J point of view, we're only really looking at the energy requirements, and that generally, in terms of fabrics, that means wall insulation to those fabrics, and also the glazing requirements. Generally, increases in wall and fabric R values means that your constructions get more complicated, and that's certainly increasing risks of condensation. So it's certainly worthwhile making sure that you're across any condensation risks, because we'd certainly expect that as the wall R value requirements become slightly harder to achieve, given the introduction of bridging, that there's certainly a risk that condensation will become more prevalent. And that's something that certainly happened, I believe, in the 90s, after New Zealand sort of increased their insulation requirements. The other thing that's worthwhile mentioning is we're seeing heaps of alterations to existing buildings coming through at the moment. As a general tip, often DTS is a sort of simpler option because only the fabrics that you're altering have to comply, or that you're adding have to comply under Section J requirements. And that's certainly worthwhile mentioning if you've got, say, if you're maybe just replacing a roof of a building, or if you're just replacing a few bits of glazing here and there. Doing a full JV3 assessment with thermal comfort is going to be much more complex, given that if you've only got minor changes to your fabrics and most of the building is sort of not performing so well because, say, the fabrics are 20, 30, 40 years old, with old glazing as well sort of mixed through there, then that's going to mean that achieving those thermal comfort requirements are going to be certainly pretty difficult, if not potentially impossible, depending on how much is changing. So if you're altering a building or working on a project like that, designing it, we'd certainly recommend discussing with the building surveyor if they believe thermal comfort should be included or not, if you're going with the JV3 option. Just a quick page on what we need as consultants. When you request a quote, generally we're after floor plans, elevations, the building class is always handy so that we know what we're assessing it as, and also conditioned areas. That's going to impact JV3 assessments. In particular, in terms of doing the assessment, the main additions are that we need more around the framing details, because obviously we've got to factor in thermal bridging so pretty much all framing details are now required really for your roofs, walls and floors. And we're going to need more information around air conditioning to complete thermal comfort assessments if you're going down the JV3 pathway. So on to our second to last slide now. In terms of, obviously this code change has brought about increase in stringency. I've read somewhere that it's around 30%. That's about sort of 7 to 10% for fabrics. The remainder made up by improvements in HVAC and lighting efficiencies, or your services. We're highly recommending that check at concept stage, or as early as possible, to sort of make sure that there's no surprises further down the track. And it can be done relatively quickly and cheaply. Maybe potentially you're only after what the glazing requirements are going to be or something like that. Certainly happy to have a chat about it. In terms of the balance between JV3 and DTS, pretty much everyone for 2016 came to us and just said, I want a JV3. We don't think that's going to be the case anymore. How that balance is going to be, we're not too sure, but it was certainly sort of in the next 6 months should be a lot clearer. And the other thing is, if you've got projects that have been underway for a fair while, it's certainly worthwhile checking with your building surveyor or certifier as to which code they're expecting you to comply to. So that concludes today's webinar. If you've got any questions, please feel free to post any comments or questions in there. Obviously, we've got a heap more webinars going on, plenty around sustainable design from our studio team, which have been super interesting. There's also our Hubble predictive star rating app, which has been created by our software development team, and there's been a heap of time on that, which is using AI to predict what the star rating requirements will be, and it's something that designers can use to quickly, or project home builders hypothetically can use to quickly identify what the likely star rating will be for their project. Doesn't look like we've got any questions for today, so thank you everyone for joining us. Hopefully you've learned something in the last half an hour. If you have any questions, please feel free to send us an email at commercial@suho.com.au or give us a call on 1300 308 525. Me or one of our other commercial team members are certainly happy to have a chat with you about if you've got any questions about the code change or any specific client advice, or project advice I should say. Thanks for joining us, and I hope you have a good afternoon.